Okay, let's dive right in. Picture this. One of your most critical cloud servers, an Amazon EC2 instance, has been hacked. An attacker could be in there right now, deleting files, stealing your data, or worse. What's your move? Today, we're going to break down the exact playbook for digital first responders.
So the alert hits your inbox. Your server is under attack. What is your absolute first move? Do you shut it down? Try to kick the attacker out? The pressure's on and every second counts. The wrong move could literally destroy the very evidence you need to figure out what happened.
Welcome to the cloud crime scene. Now, this isn't like a physical room you can just tape off. Our evidence is virtual, it's constantly changing, and it's incredibly fragile. Investigating a breach in the cloud, well, it isn't just a technical challenge, it's a flat-out race against time in an environment that's designed to be temporary.
And this really shows you the heart of the problem. Your evidence is scattered everywhere. You've got different kinds of logs, and a lot of them might disappear after a short time by default. You also have way less control over the physical hardware. You might be dealing with data stored across different countries, and all the while, the attackers are doing their best to cover their tracks. It's a whole new ballgame.
So what are we actually talking about here? Well, at its core, cloud forensics is just taking those classic digital investigation principles and applying them to the cloud. It's a specialized field for sure, with its own unique rules and a bunch of gotchas that are absolutely critical to master.
Now, before we even think about grabbing any evidence, we have to understand the rules of engagement. See, in the cloud, you don't own the whole shebang. There's this agreement between you and the provider that lays out who's responsible for what. It's called the shared responsibility model. And for Amazon Web Services, it looks kind of like this. AWS takes care of the security of the cloud. We're talking the physical buildings, the servers, the big network cables, but you're responsible for security in the cloud. That means your data, your apps, your operating systems, and you guessed it, your incident response. The forensic investigation, that lands squarely on your shoulders.
Okay, so with all that groundwork laid, let's get to the main event, the playbook. This is the definitive 6-step process for forensically acquiring a compromised Amazon EC2 instance and preserving that evidence so your real investigation can begin.
We're going to walk through each one of these. We'll isolate the target, grab a perfect copy of its hard drive, set up a totally clean lab environment, and then carefully mount the evidence so we can examine it. This is the standard, repeatable method you've got to know.
First things first, we secure the crime scene. We immediately swap the instance's security group to a super restricted one. This thing acts like a digital firewall, blocking all traffic trying to get out. That stops the attacker from stealing more data or phoning home. We contain the threat right then and there. Next, we photograph the evidence before we touch anything. By stopping the instance first, which makes sure the data isn't changing while we copy it, and then taking a snapshot of its virtual hard drive, we're creating a perfect bit-for-bit copy of the disk at that exact moment. This snapshot is our primary evidence. It's immutable.
All right, steps 3, 4, and 5 are really all about one thing, setting up our forensic lab. We spin up a brand new, totally clean EC2 instance to be our workstation. Then, we create a new usable hard drive from that snapshot we just took and attach it to our workstation. And here is a super crucial point. The workstation and that new evidence volume must be in the same availability zone. Think of it like a specific data center building. If they're not in the same one, they just can't connect.
We are now at the final and, honestly, the most forensically critical step of the whole acquisition process. We've got the evidence drive attached to our clean workstation. Now we need to actually access the files on it so we can start our analysis.
But hold on, this raises a huge question. How do you actually look through all the files and logs on a drive without accidentally changing a timestamp or writing some new log file, without contaminating your pristine evidence?
And the answer is this magic little command right here. Specifically, that tiny little flag -o row. This command mounts the evidence volume in read-only mode. This is, without a doubt, the single most important part of this process. It is the digital equivalent of handling evidence with gloves. You can look at everything, but you absolutely cannot change a single bit.
And just like that, the acquisition is complete. We've got our evidence, and we've collected it without messing up the digital crime scene. Now the real investigation begins. It's time to decode the digital clues the attacker left behind. Okay, let's make this real. Imagine an attacker got in and deleted a supercritical file from an S3 data store. See, with the right logs turned on, this whole process isn't just about one server. It's about your entire cloud environment. So how do we find the culprit?
This is where tools like Amazon Athena become your best friend. You can run queries, basically ask questions, over your access logs to hunt for specific things. So as you can see here, we can write a query to find out exactly who, which user, from what IP address performed a delete on our specific file, and the exact time it happened. This is how you unmask an attacker.
Now, we've focused a lot on AWS because, well, it's everywhere. But the principles we've just learned are universal. The digital world is way bigger than just one cloud provider.
If your stuff is running on Microsoft Azure or Google Cloud, the specific commands and the buttons you click will be different, for sure. But the core forensic goals, they stay exactly the same. Because ultimately, it doesn't matter which cloud provider you use, these core principles are constant. You must always create a perfect, unchangeable copy. You have to isolate the evidence. You have to perform your analysis in a clean environment. And you must make sure you don't alter that evidence by mounting it in read-only mode. This is the foundation of all digital forensics.
So as we wrap up, let's look to the future. We live in a time of infrastructure as code, where servers can be spun up and torn down in a matter of minutes. In a world where the crime scene itself might only exist for a few seconds, what does that mean for the future of digital evidence? It's a big question and definitely something to think about. Thanks for joining me.